Good morning. I am Reggie, Associate Professor, Department of ECE. Today in this session, we are going to discuss about waveform distortion. What is a waveform distortion? On completion of the students will be able to understand what is a frequency distortion, phase distortion, distortionless condition, etc. Waveform distortion. In an ideal transmission line of a signal through the transmission, when the input or the sending end is not the same at the receiving end, then the signal is said to be distorted. That is, whatever signal we are sending from the input will not be equal at the receiving end, then the signal is said to be distorted line. Distortions are classified into frequency distortion, phase distortion. Frequency distortion, the attenuation constant alpha is the function of frequency. The signal transmitted along the line will be attenuated to different extent. For example, a voice signal consists of many frequency will be transmitted along the transmission line, and all the frequency will not be attenuated equally along the transmission line. Hence, the received signal is not the exact replica of the input signal at the sending end. Such distortion is called frequency distortion. So, alpha equal to square root of Rg minus omega square Lc plus square root of Rg minus omega square Lc the whole square plus omega square Rc plus Lg the whole square by 2. Phase distortion, beta is equal to square omega square Lc minus Rg plus square root of Rg minus omega square Lc the whole square plus omega square Rc plus Lg the whole square by 2. We know that omega is equal to velocity is equal to omega by beta. Phase distortion depend on frequency. Thus, the velocity of propagation varies with frequency. So, some of the signal received from the recipient will be very fast, while some waves will be delayed at the other. Hence, the receiving end signal is not the exact replica of the input. Such distortion is called phase distortion. Distortionless line. Distortionless line does not distort the signal phase, but it introduces a signal loss. They are not superior conductor. They are called heaviside distortion. Alpha equal to square root of Rg minus omega square Lc plus or minus square root of Rg minus omega square Lc the whole square plus omega square Lc plus Rg the whole square by 2. The value must be made independent of frequency by making Rc plus Lg equal to 0. Hence, the distortionless condition is Z equal to R plus JL, Y equal to R plus JG, gamma equal to R plus G. So, Y is equal to gamma is equal to alpha plus J beta, and gamma equal to root ZY. So, gamma we know that is at R plus J omega L, G plus J omega C. So, gamma is equal to multiply both sides. You will get the value Rg plus omega, Rc plus J omega Lg minus omega square Lc. And we can separate the real part and imaginary part, and you substitute Lg plus Rg equal to 0. So, when you apply the condition gamma equal to Rg minus omega G of 0, finally you will get omega is equal to square root of Rg minus omega L square, or omega square is equal to Rg minus omega square Lc. So, if you substitute both the value, we know that gamma equal to alpha J beta. So, alpha is equal to root Rg and beta equal to omega square. Here the phase velocity Vp is equal to omega by beta. So, omega by omega root Lc. So, Vp is equal to 1 by root Lc. So, these are about the waveform distortion. So, question number 1. Phase distortion is otherwise called as